Thanks for your coming. This is a joint work between me and my student. I'm the supervisor for those people. Can you hear? Can you hear me? Okay. So here's the paper title. And for the outline, first I will give an introduction for this work. In particular, I will talk about machine reading comprehensive, MRC, large language model, model comprehension, knowledge distillation. And also, the second, I will give you an introduction, a brief introduction of the motivation of our proposed research. And after that, I will give a very brief idea of the proposed framework, MTMS. You may read the paper for more details. And for sure, I will give you some discussion about the experiments, in particular the data sets, performance, and ablation study. Finally, I will show you the summary and the conclusion of the work. So it's a pretty standard presentation. Okay, so for the machine reading comprehensive, called MRC, basically it is one of the key problems in natural language understanding. So the task is to teach machine how to read and comprehend, how to read and understand a given passage, and then answer question based on it. So basically, this is a very standard research problem for the natural language understanding, which is very important for the information retrieval, because traditional information retrieval basically based more on the statistical information. That's what I did when I studied my PhD a long time ago. And right now, we try to go to a little bit deeper level, try to understand what the document, what the passage means, okay? So how can we do that? One of the solutions maybe currently things is pretty good is through the large language model. So basically they have a big, huge training data, try to understand the correlation, association of those keywords and tags, keyword in the document through this large statistical information. I don't think they really understand what human beings understand. Okay, so the input to the MRC model is a question and a context paragraph or passages. The output to the model is the answer from the passages. Okay, so for example, I think I have in pretty short time. I will try to make it fast. The example is the San Francisco Giant, an American professional baseball based in the San Francisco, California. So founded in 1883 and so on in New York, then renamed it, then moved to San Francisco, okay, in 1958. So for us, it's very easy to understand, oh, I see where they come from. But for the machine, like my background is probability-based model, so which I studied my PhD in England. And we actually not really understand these things. We just based on the distance, frequency, and sort of understand. But then right now, we show the machine reading on the comprehensive, we try to understand, oh, this thing, even though in San Francisco, but the answer is that should come from New York. Okay, that's what the human beings can do. Okay, so basically that's what we try to do for this work. Okay, and how many solutions for this kind of task? There are 4 usually. One is a Crosby style. The second one is multiple choice and span extraction and free answering. Okay, so I will show you very briefly, and then I will talk about what we are focused on in this task. So the Crosby style is we try to find which text entity extracted from the textual context is able to fill in the blank in a sentence with missing words to meaningful complete the answers. Okay, so you can see this example. I hope you can see clearly. I couldn't see very clearly. So basically, the answer is ENT 193. The second one is a multiple choice. That's the most easy one for us to understand. So because most of the international students, they probably attend the TOEFL exam, GRE exam, GMAT exam. So that's basically what we are doing. So basically they give you like 4 choice, a list of the choice, and then you choose the right answer. Okay, so that is the one we are focused on in this research. So actually it's pretty simple. So there's some other things like span extraction, extract a span of text from a given context that can represent an answer for a question. So for example, this one highlighted in the blue color is the answer, okay? And the last one is a free answer. So we try to dramatically generate an answer which a sequence of a word that may not necessarily answer in the text, but which is the semantically coherent and appropriate to the answer. So basically ChatGPT is a kind of tools that can do this kind of work. Okay, so but in this research we are not focused on this one. We only focus on multiple choice. Oh, okay, so our work focus on multiple choice MRC tasks. So mathematically, I will not spend too much time to explain the mathematics. Otherwise, you will feel boring and fall to sleep. So basically, the problem is that the feature of a multiple choice is a list of the candidate answer. A1, A2, until AN is given, that we can act as a complementary information to predict the answer. So for example, like this. So given the context C, the question Q, and a list of the candidate answer A, which include A1 to AN, the multiple choice task is to select the correct answer AI from the A by learning the function F, that is AI equal to F and the CQA. Okay, so mathematically it's quite simple, but how can you solve the problem and how can you find a better solution? That is the key part of this research. There are many solutions, I believe so. Okay, so, and the second about the large language model. I found the large language model is getting crazy, okay? So almost everybody talking about the large language model. Actually, I'm also in the learning process. It's quite brand new. I still remember a couple years ago, the BERT is so popular, everybody is talking about it. Right now, BERT seems to become out of date, and the large language model come out. I'm not sure 1 year later what kind of a model will be. It seems it will be super large language model. So large language model, LLM, are a category of a foundation model trained on the huge number of amount of data, making them capable of understanding and generating natural language and other type of content to perform a wide range of tasks. So this is a diagram I copy-paste from a paper, which hopefully you can see. It's a survey paper. I'm not sure it's published already, but it is on arXiv, okay? And last night, I just read how famous this paper. This paper was posted on the arXiv. It has almost 2,000 citations already. So it's getting crazy. So it seems the arXiv will become a popular place to advertise your work, even though the paper may not has not been officially published yet. I'm not one of the authors, but some of my friends are also of this paper. Okay, so basically you can see that this is a very good diagram. It shows you the evolution of the large language model in the past few years. How can they become more and more popular, and what's the parameter inside? Okay, so it's a good diagram. I don't think there's much novelty inside, but it's a good diagram. And as you can see from this table, and how many parameters involved for each large language model. Why I'm talking about this large language? Because this research is strongly related to large language model. That large language is so great. So what's our job? So yesterday I had a talk with someone. I forgot exactly. They said, "What are your professors doing in the future?" Because large language model is a super powerful, and maybe they can replace professor job. They don't need a taxi driver, don't need a salesman, don't need a hotel people. Even we don't need a professor, because a super large language ChatGPT may looks like can answer a question much better than even by a professor, than the most famous professor in the IR like Steve Robertson, Bruce Koff. Okay, but actually not. We will not lose job if we found the problem. So I will show you how exactly what we can do, what's our responsibility. So for example, what are the challenges? So when we found something looks great, then maybe something we still can solve, okay? Nothing go to the end, okay? our knowledge is far beyond go to the perfect. So what are the challenges? One of the challenges is large language model demand substantial computational resources, memory, and power. One of the easy way to understand is the parameters that you need is huge, okay? Even more than our brain cells inside. It's beyond our imagination, okay? So it's very, very expensive, okay? So also large language model enormous scale lead to significant expense and limited the development, deployment in the real application. Because most of us, we are not OpenAI, we are not a very huge company, we are not so rich, okay? So we need to solve the problem. We need to use large language model to solve the problem, okay? If you're running a small company, or if your company are not so rich, how we can deal with it? We don't have so much computer resources. It's just impossible. So I will show you what we try to do. So what we're thinking about is, can we try to have a small model, at least a relative small model? We do not need such a huge resources, okay? But the small model can also has the capability or the knowledge of large language model. So that's basically what's our motivation. I think this is more important. That's what I talk to my student. The detailed implementation and stuff, they are excellent students, they did the work. So one of the things we do is we try to use the model comprehension called knowledge distillation, okay? So what is the model comprehension? Refers to a set of algorithms that aims to reduce the size of, I try to make sure the time I finish in time, the size of memory requirement of the neural network without significantly impact their accuracy. This can help make model more efficient and cost effective, allows them to be deployed on a real-time environment. So you can see that what we try to do, we try to reduce the parameter, the memory requirement, CPU, GPU, whatever, but we try to also keep the capability of the work to do the prediction. Okay, that's what but it's hard, I know, but we have no choice because we are not OpenAI, we don't have multi-billion or 100 billion US dollar to fund our research. If you have so much money, I don't think you need to worry about the job. The president of the university will follow you like small kids because you bring the money for them. But that's impossible. So I will show you. So basically, first, we need to answer how many solutions, how many possible solutions we can do. So comprehensive modeling techniques are roughly divided into 4 categories. One is the parameter pruning. The other one is the low-ranking factorization. And third one is knowledge distillation. And the fourth one is the quantization. Okay, so there are 4 solutions. What we try to do is the third one. Okay, so that's what our research focus on. So knowledge distillation is a technique that enable knowledge transfer from large computational expensive model, like for example in our case a teacher, to a small online student without losing the validity. This allows us to deployment on a less powerful hardware, making evaluation faster and more effective. So there are many solutions. A lot of techniques, modeling, they kind of solve this problem. That what we try to do is I will show you later. So this is basically our motivation. Our motivation is how can MRF techniques could be more effectively applied in a resource-constrained mobile device. For example, we use a mobile, we can try to do all this work, but actually it's happening right now, okay? So a lot of tools that are available on the mobile device. And also how to transfer the logic reasoning capabilities of large language model to small model. So actually that's what we are thinking. Everybody talking about large language model, everybody talking about the big data. So we are thinking about small model with the same functionality. We are talking about more small data, not big data. I still remember when I started my PhD, I remember Steve Robertson doesn't know programming too much, but his mathematics is really good. So he just used some mathematical statistical formula to analyze it, but he can get pretty much a similar result when you conduct a large number of experiments. That's what I did, using programming language. So finally we understand that. So when you cook a big soup, right, a container, you try to see how the soup, whether it's tasty or not. You don't need to drink all the soup. You just drink a spoon, and then you can see whether the soup tasty or not. So that's basically the idea, but people may not use it in the real application. So the basic idea, what we did is, how much minute I have? Not too much, 5 minutes. Okay, I can finish it. So basic idea is we design a multi-teacher distillation framework that includes both a logic teacher and a semantic teacher. So basically the idea is a reasoning-based experts from one of the data set we use is the logic teacher focus on understanding the logic relationship in the text, while the semantic teacher concentrated on the basic semantic relation. And then we use the different level to learn and try to transfer the knowledge from the large language model to a relatively small model, like in the student level. So what we do is the basic idea is we also propose a multi-stage learning strategy where the student model engage in a constructive learning, so which is popular right now, with the teacher model at each stage, and slowly, step by step, approximately the level of the teacher. So basically, we through this multi-level learning process called constructive learning, we can try to transfer the knowledge in the higher level, which is big model, to the lower level, to the student, which a much smaller model. Okay, so the step for this framework is that I will say very briefly. The first step is the logic teacher, Tau 1, and the semantic teacher, Tau 2, utilize the L-layer graph neural network to model the feature of the graphic nodes based on the logic and the semantic graph. Then the second step, the student model, S, will the processing through an L-layer graph transformer network engage in the progressive constructive learning process with the two-teacher model at each level, then substantially enhance these learning capabilities. The final step is the student model S undergoes effective training guided by the soft label based on the logistic, the work, and which showing this diagram. It's not very clear, but I can give you the slide if you want to know the detail. So after we decide, the idea is much more complicated. We spent about 3 pages to write this paper. So a lot of mathematical formula inside, you can have a look later on, but let's not focus on math part. So I will show you how we can evaluate, because SIGIR is a conference that really focus on the evaluation, not like in some other conference, like algorithm, computation theory, or some IIIE, you may not have experiment, then your paper still can be accepted. But SIGIR, if you don't have experiments, there's no way your paper can get accepted. Even you got the Nobel Prize, but there's no way. So the data set we choose is actually 2 data sets, not the standard data set like track conference. We have been used track conference data set, which the Donald got a Southern Award. His main job is to provide all kinds of track data set and the platform so that we can do the experiments. We use 2 data sets. One is RECOO, the other one is LGI QA. And the first one is more kind of American generated for the GMAT and also the lawyer school administration test. The second one is a more kind of a Chinese data set, which is government, because the government job sponsor, usually more and more people like it, not in my age, so they have to test the experiment, give you a test, so that in order to be admitted. So this is the analysis of this data set. As you can see, how many training data, developing side, testing side, totally. So it's not small, but not big either. And here's the experiments. I'm going to close to finish. So as you can see the experiments, so basically the comparison baseline result has 3 parts. One is the lemma and ChatGPT, and the other one like eBird and so on and so on, and the reporter and so on and so on. As you can see, this is the method we propose, and this is the baseline method. So basically here is the number of parameters. P stands for the billion. M stands for the million, and T stands for the small t, and T stands for trillion. Okay, and then this hidden layer, and this is the hidden layer unit, and this is the accuracy result, because multiple choice is easy to calculate, and this is the improvement. And you can see our proposed method, since they have less parameter, less hidden layer, less hidden size, but accuracy is better compared to the baseline method. Okay, so you can see more detail, and this is the result on the other data set. Okay, and we also do the ablation study on the 2 data set I choose, and as you can see, we use the our proposed method, and this is the one on the multi-teacher layer without semantic teacher, without logic teacher, and this one on the multi-stage learning without the multi-stage learning or only one stage multi-learning. And the performance result shown here, and this is the result, best result for the proposed method. As you can see, the method is good. Okay, so, and I'm done. Close down. And then this is another data set and summary. So first, we propose a new knowledge distillation method. And second, we develop a multi-teacher distillation. I always cannot pronounce this word correctly. I try to. English is not my mother. I asked my daughter, and it's so easy for them to pronounce this word. Framework that include both a logic teacher and semantic teacher, provide a comprehensive and targeting guidelines to the student layer. So, we also incorporate this multi-stage constructive learning process into the whole framework, and it works pretty good. So we conduct serious experiments, and which demonstrate that our proposed framework achieve effective performance with actually a much smaller number of parameters. So the future work for the resource computation resources reason, we didn't try all the baseline. Some baseline may be even better, I guess. And the further work include, we try to further improve the generalization and the robustness of the model. And finally, we have to acknowledge all the grant support and also the co-author, and they provide excellent contribution for this work. And the end is thank you. So I